Welcome to our session. I'm Patty Feltz. This is product marketing for u-blox services. And today our topic is solving the complexity of communicating sensor data between IoT devices and the enterprise. Let's begin. It needs to be extremely easy to get data from the IoT device into the cloud. And we find that communication is so much more than just the connectivity. Choosing the right protocol is key to a successful IoT device project. We will review the benefits of MQTT SN for IoT sensors applications and how to overcome challenges like complexity, cost, and availability. Lastly, we'll go over a case study. This case study involves wind turbine blade monitoring. So let's begin. It's hard to communicate data between a device and the enterprise. At first, it seems really simple. You've got a device with some important data. There's a network, there's a cloud platform that is interested in receiving that data. But if we take a closer look, it's not so simple. There's a lot of questions to be answered, complexities to be solved. What connectivity should we use? Which network? How do I scale? Is it secure? What about the power consumption or data usage involved in the design? What's the interface to select to get that data to the cloud, and what's the cost? So all of these are calculations made into any successful IoT design. When we consider IoT use cases, such as those, what emerges is really certain characteristics that define the scope and the range of which these use cases reside. And those are shown here. We might consider condition monitoring, a container tracking, pet tracking, or connected healthcare. We become concerned about the payload size. That payload size might be between 500 bytes or even as small as 50 bytes. The message frequency could be as infrequently as just a message once a week or so, or very frequently every minute. And battery life, we're looking at a range of devices that are recharging once a week, a weekly lifespan, or devices that are never recharged and are expected to live in the field for 5 or 10 years, their entire lifespan. So many of these IoT use cases are under these types of parameters and constraints. They're going to utilize a low power wide area network. And so these networks have certain features such as power save mode and EDRX, extended discontinuous reception, which offer benefits of improved power consumption. Only that the network operators themselves are determining the effectiveness of those features. So what emerges is, if you want fast, secure communication to the cloud, there's a major impact on the battery life, and the choice of protocol really becomes a key decision. So choosing the right protocol is key. And what we're doing here is using the analogy of packaging. You can think of your data or your payload as the message, and the protocol is sort of the packaging, the envelope that is surrounding your message. And you can see that there's a range of sizes associated with this packaging, as small as an envelope to the left for MQTT SN. CoAP might be represented by a bubble wrap envelope. And over on the right, other protocols such as HTTP feel more like a cardboard box that you're shipping your package in. And then adding a security layer there feels like a big cardboard palletized box, very, very heavy. So again, in this constrained environment, we want to be making a smart selection for protocol to be as efficient as possible. And so, of course, we're going to lean toward the left side of the envelopes here, packaging, the MQTT and MQTT SN protocols. MQTT has really quickly become popular for IoT. It's a publish and subscribe protocol that is specifically designed for machine-to-machine communication, and it has quality of service levels available specific to the requirements of the application. It's easy to use, it's reliable, very lightweight, and can scale. MQTT SN, the SN standing for sensor networks, is even further tailored toward the need of sensor networks. Again, it is a publish and subscribe protocol. And you can see here in the little diagram that sensor values are published over to topics. And there's a very important element here. The MQTT broker is managing those topics. And over on the right, applications are subscribing to those topics. So this publish and subscribe model becomes important because this is what is driving efficiency. A little bit more about an MQTT client and broker. We really don't think about client and server anymore. We want to think of this in terms of a client and a broker. So the client can be anything that runs an MQTT library and connects to the broker. That can be a client. Clients don't message each other directly. Things are sending and receiving messages via topics, again, the topics, and that's managed by the broker. So the broker is really acting like a signpost, a traffic light, and the broker is handling authentication, managing those connections and sessions, responsible for sending messages as topics to the subscribed clients and queuing up the messages according to their quality of service. So let's go through a couple of ways this impacts battery life. So we'll go back again to this analogy about the packaging. So the smaller the overhead is, the smaller that overall message is going to be, and thus low message overhead means longer battery life. Security also can impact battery life, which security you're choosing. So here we see a comparison of a typical track and trace application. On the left, we're using SSL or TLS, and that's contributing 6 kilobytes in overhead, whereas a secure end-to-end communication using MQTT SN is 26 bytes. Very significant difference in the security impact to overhead. And again, that's contributing to power autonomy or battery longevity. Another way to think about this is time spent on the air. So request and response protocols such as CoAP or TCP, shown on the left, need more time on the air to transact those requests and response. Whereas a publish and subscribe protocol like MQTT-SN needs less time on the air. So again, that time on the air is directly impacting battery longevity. Okay, so let's see these statements in action with some data. This is a bit of an eye chart, but hopefully you can see these nice hero red bar chart and understand very quickly that the MQTT protocols are more efficient. So shown here on the right are the number of bytes sent for just a simple payload of 12 bytes, a hello world payload. And you can see very quickly that protocols such as HTTP or even HTTPS have a huge inflationary factor for the number of bytes that need to be sent. Again, due to that overhead. On the left is a similar diagram showing the relative power consumption. So really power efficiency becomes important for a couple of reasons. The overhead being introduced by the protocol is impacting the power consumed. And these highly inflationary protocols are using up your data allowance all on the overhead. It's not on the payload, and it's the payload where the actual value lies in the message. There's no value in the overhead. It's actually wasteful. All right, let's jump into a case study. And this case study is published to our case study webpage. It's the URL is shown on the right in the bottom. It's entitled Intelligent Listening Enables Innovations in Wind Energy. So we will introduce to you a customer called Ping Services. So Ping Services really are experts in acoustic engineering and in developing acoustic sensors. So Ping Services realized that in the wind turbine blade industry, a site technician, when the site technicians are going around these wind farms, they can hear the damage. They can hear a damaged blade has a different audible sound than a healthy blade. So if a site technician can hear that damage, hear that sound difference, then a smart sensor can do the same thing. So Ping Services really innovated here, and they developed an acoustic sensor that can detect damage on these wind turbine blades. And this is very innovative. This is a first in the world of using the acoustic measurements to detect damage. And this really helps their customer because early detection reduces repair costs and avoids very, very costly replacement of the blades. Next, we're going to move on to a design partner of u-blox called Lattech Systems. So Ping Services, they're experts in acoustic sensors, but they're not experts in connectivity. So they reached out to Lattech Systems to ask for support to complete this design. And it was, you can see here on the right of the photograph is the acoustic sensor itself. And on the left is a connectivity, communication and power control module, which was developed by Lattech Systems. And their goal was to really make it completely invisible to the customer, getting data from the IoT device into the cloud. It needed to have simple connectivity, something that would work globally, no setup, plug and play. The customer could easily install this, and it needed to be easy to get data from the device to the cloud platform. And that's really where u-blox has come into play here. Just a little bit more details about this communication and control module. What you see here, the black surface is a solar panel. So all of the required energy is for both the sensor and the communication module is harvested through solar panels and completely powered that way. All right, let's look inside that box and see what's in there. So there's a number of u-blox hardware components in there, but the one I want to talk about and feature today is shown in the circle there. They are using the MQTT Anywhere IoT SIM card to get that data from these devices on the wind turbine blades up to the cloud. So just to review, right, this IoT SIM card has access to 600 cellular networks in 190 countries. So this is enabling a global rollout of this particular application. The MQTT SN gateway is giving that efficient, connectionless, low power communication. We've got predictable pricing here. So the pricing is not based on the amount of data sent, it's based on the number of messages sent per month. So customer has complete visibility and understanding and predictability of pricing. And again, back to that publish and subscribe method. What's available here and included is access to that MQTT broker. So we've got a scalable broker and cloud platform that this customer can use globally. And so that's sort of the secret sauce inside that communication and power module. So we can see here, to kind of wrap it up, that There's many challenges in getting hidden challenges in getting data from the device to the enterprise, and these are solved through solutions provided by u-blox. We find that connectivity is really only one component of the overall low power solution, and choosing a protocol is key. That's an important decision. And we at u-blox are offering a whole suite of IoT communication solutions that utilize that protocol, MQTT, and allowing our customers to solve that device to enterprise challenge.